It is x cube. Its coefficient is 1. So 1 is equals to 0 is not possible. So asymptote doesn't exist parallel to x-axis. Right? Now, say the highest degree term in y is y itself. So collects its coefficients. So coefficient is 1, equate it to 0. So 1 equals to 0 is not possible. So asymptote doesn't exist parallel to y-axis also. So asymptote does not exist. Right? So next, rule 4, special points. So in the special points, what we're going to check only tangents at the points of intersection, whether tangent at these points are parallel to x-axis or parallel to y-axis. That will decide actually the nature of the curve. Right? So we'll find out dy by dx here. So dy by dx is 3x square minus 1. So see the value of dy by dx at plus minus 1 comma 0. So value is finite, right? It's 2. Okay. So it means there is an angle between this tangent and x-axis other than pi by 2 and 0. Okay. So its nature will be like this. Okay. So what does it mean? That tangent at these points are not parallel to y-axis and x-axis. Right? Now next rule, rule 5 is a region of absence of curve. Okay. So region of absence of curve. So say here y is equals to fx, explicit form is there. Okay. So for this y equals to fx. Okay. We'll check the region of absence of the curve, whether curve exists left to the minus 1 comma 0, whether it exists between minus 1 comma 0 to 0 means origin, whether it exists between origin to 1 comma 0, whether it exists between right to the 1 comma 0 or not. So we'll first take the values, any value left to the minus 1 comma 0. So it is minus 2. So for x is equals to minus 2, y is not imaginary. See, what you're observing here, y is equals to x into x square minus 1. So value of y for all x is real, right? It will not, it will never be imaginary because y square term is not there. It is y. So the value of y is always real for all values of x. Therefore curve exists in all intervals. Curve exists in all intervals. Means curve exists left to the minus 1 comma 0. Curve exists between minus 1 comma 0 to origin to 1 comma 0 and 1 comma 0 to infinity. Now we'll see the nature of the curve here. Okay. See, this is now important. Here, see, the curve is passing through origin. What's a tangent at origin? So this tangent will decide the nature at origin. Okay. So y is equals to minus x is the tangent at origin. So curve is passing through this origin and this point 1 comma 0 also, but curve does not stop to exist here. It continues in the interval 1 to infinity. Okay, therefore there won't be loop here. Loop, when it will be a loop, if curve ceases to exist, stop to exist on either side, so it doesn't stop to exist on any side. Okay, so there won't be loop here. So it passes through origin. Tangent at origin is y is equals to minus x, and it passes through 1 comma 0 also. So since y equals to minus x is the tangent, so its nature will be like this, right? Nature will be like this. So it passes through the 1 comma 0. So here tangent doesn't parallel to y-axis, doesn't parallel to x-axis. It's something else. So definitely, so its nature may be like this. So tangent may be like this here. All right. Now see here, it passes through origin as well as minus 1 comma 0. So tangent at origin is y is equals to minus 1. So its nature will be like this definitely. And it passes through minus 1 comma 0. Here tangent may be like this, right? That we have seen. Okay, so this is the rough nature of the curve for the equation y is equals to x into x square minus 1, right? So we'll see another example so that you get again a more clear idea. Second example. Y square into x minus a equals to x square into 2a minus x, right? Okay, we'll simplify it first to get the tangent at origin and asymptotes. Okay, it will be better to simplify. Okay, so what's the simplification? This x y square minus ay square minus 2ax square plus x cube equals to 0. Okay. Now, rule 1, symmetry. So see, whether power of x is even, power of y is even everywhere. So we'll see the simplified example. Here, power of x is 1, it is 2, it is 3. So power of x is not even everywhere, so it is not symmetrical about y-axis. Now we'll see the power of y. It is 2 here, it is 2 here. Okay, so power of y is even everywhere, and therefore curve is symmetrical about x-axis. Curve is symmetrical about x-axis. Right? Rule 2, origin. So equation is satisfied by 0 0. Therefore curve passes through origin. So we need to find tangent at origin. So for tangent at origin, what we do, we collect the lowest degree terms together and we equate it to 0. So see the lowest degree terms. So first we'll see the degrees of each term. So degree of this term is 3, degree of this term is 2, degree of this term is 2, degree of this term is 3. Okay, so lowest degree is 2. So lowest degree terms are minus ay square minus 2ax square. So we'll collect this and we'll equate it to 0. So what we'll have? We'll have ay square is equals to minus 2a x square, and this gives y imaginary or x imaginary. And since y is imaginary, x is imaginary, right? Tangent at origin does not exist. So tangent at origin does not exist. So curve is passing through origin, but tangent at origin doesn't exist. Since y is imaginary or x is imaginary, we are getting. So next, points of intersection with coordinate axis. So put x is equals to 0. What will have? Y 0. Right? So origin is only the point of intersection with y axis. Now second, we'll put y equals to 0. So if you substitute y equals to 0, what will have? X square equals to 0 or 2a minus x equals to 0. So what we are getting here? Origin and 2a comma 0. Okay, so origin and 2a comma 0, these are the points of intersection with x-axis. Okay, so we'll draw the curve simultaneously. Origin so it passes through origin. There's tangent doesn't exist at origin, x-axis, y-axis. Now points of intersection with y-axis origin, points of intersection with x-axis origin and 2a comma 0. So this is a 2a comma 0. Okay. So curve pass through this point 2a comma 0. Okay. So rule 3, asymptotes. So to get asymptotes parallel to coordinate axis, say asymptote parallel to x-axis. How we get it? Collect the coefficients of highest degree terms in x. So highest degree term in x is x cube. Its coefficient is 1. So 1 equals to 0 not possible. Therefore asymptote doesn't exist parallel to x-axis. Now we'll go for highest degree terms in y. Highest degree term in y is y square. Its coefficient is x minus a. So we'll collect it and we'll equate it to 0. So x minus a equals to 0. That is x is equals to a is the equation of asymptote parallel to y-axis. So x is equals to a means this line. So x is equals to a. This is asymptote. Right? Rule 4, special points. So in the special points, again, we are not interested in curves, node, points of inflection. We'll see whether the tangent is parallel to x-axis or y-axis at 2a comma 0. We have seen already at origin tangent doesn't exist. Now at this point, we'll just check whether tangent is parallel to x-axis or parallel to y-axis. We are not interested in other tangents. Okay. So we'll find out dy by dx there. So we'll write y square equals to x square into 2a minus x divided by x minus a. So differentiating this with respect to x. So what will have 2y into dy by dx equals to, if this is fx, then take its derivative. You can do it later on. So what will have dy by dx equals to f dash of x divided by 2y. Okay, so I'm not interested here to find out this f dash x. You can do it. Okay. So substitute x is equals to 2a and y equals to 0 here. Means get this dy by dx at, therefore dy by dx at 2a comma 0 is infinity. So what does this implies? Tangent at 2a comma 0 is parallel to y-axis. Tangent at 2a comma 0 is parallel to y-axis. So I'll show this tangent by dotted lines. Okay, so this is the tangent at this point, which is parallel to y-axis. Now last rule, a region of absence of curve. So we'll check a region of absence of curve here. So we have y square equals to x square into 2a minus x divided by x minus a. See, we'll check whether curve exists left to the origin. It exists between origin and asymptote. Whether it exists between asymptote and tangent, or and the point 2a comma 0 and right to the 2a comma 0. So we'll check it one by one in these intervals. So left to the origin, you can take any point, say x is equals to minus a. So for x is equals to minus a, we'll just see the nature of y square, whether it is positive or negative. We are not interested in value. So x is equals to minus a. So for x is equals to minus a, we'll see whether y square is negative or positive. So x square is always positive for any value. Okay. See, 2a minus x. So x is negative here. So this is positive. Right? Minus a is negative. So numerator is positive, denominator is negative, and therefore y square is negative. Means y is imaginary. Therefore, no part of the curve will exist left to the origin. So left to the origin, there is no curve. Now between 0 to a, this is the asymptote x is equals to a. This point is a actually. So 0 to a, so we'll select any point, say x is equals to a by 2. Okay. So for x is equals to a by 2, we'll see whether y square is negative or positive. So x square is always positive. See, 2a minus a by 2. So of course a by 2 is less than 2a. So it is positive. Now a by 2 minus a. So a is greater. So it is negative. So y square is negative. Therefore, no part of the curve will exist between x is equals to 0 to x equals to a, right? So between these two lines, there's no curve, right? Left to the origin, there's no curve. Now, we can say left to the asymptote, there's no curve. So third, between a to 2a. So we'll select any value, say 3a by 2. Okay. So for 3a by 2, so we'll see y square, negative or positive. This is positive always. 2a minus 3a by 2. So of course 2a minus 3a by 2. So this is less than 2a. So it is positive. X minus a. So 3a by 2 minus a is positive. So y square is positive. Therefore curve exists between, say, you can say asymptote and the point 2a comma 0. So curve exists between these two, all right? So here curve exists, so here curve doesn't exist, curve doesn't exist. You can say here curve exists. Now left to the right to the 2a comma 0, we'll take any point, say x is equals to 3a. So y square is, so x is equals to 3a. So 2a minus 3a negative, x square is always positive, 2a minus 3a negative, 3a minus a positive. So y square is negative. Therefore no branch of the curve will exist. No curve will exist beyond x is equals to 2a. Right? So there is no curve beyond this. Now we'll see the curve, nature of the curve here. See, it passes through origin, right? But there is no branch here. There is no branch here. Okay. It passes through 2a comma 0. Tangent at 2a comma 0 is parallel to y-axis. So curve doesn't exist right to the 2a comma 0. It exists left to the 2a comma 0. And since tangent is there parallel to y-axis, so nature will be like this since tangent is there. Okay. And it will extend like this because x is equals to a is the asymptote. Okay, and asymptotes are tangent at infinity, so nature will be like this. So this is the rough nature of the curve for the equation y square into x minus a equals to x square into 2a minus x. So this is rough sketch for this curve. Thank you.